Hello, one. So we have a number 29 on the sprint test. So let's see what we have. So we have a coordinate plane and two curves intersect at 4 points, and we want to find the area of the quadrilateral with those vertices, and that will be in radical form. So the first thing is this is sprint test, and we don't want to really do so much work. Like when you have a system, you can take a variable and plug into other one, like substitute and kind of try to go from there. But when you do so, like you have the fourth degree, so which is why it doesn't really work well. But you can still get a solution out of that. So I'll just let you enjoy that. But for now, let's try something else. So one of the things that you probably see, you kind of have like somehow a symmetry going on, because if you swap x and y in both equations, you still get the same system. So there's no change. So whenever you have some sort of like symmetry, it is actually like nice to kind of use that for our advantages. One of the ways to kind of use it, like maybe graph it and get all the coordinates, so because you can get the coordinates easily. So if you like recognize this is kind of similar to the equation of circle, let's say we have x squared plus y squared is equal to r squared. So this is a circle that is like centered at origin, but this is the fourth power, so that is not complete a circle, but it's something else. But at least it's gonna behave something similar to this one. So at least we know that if I have a circle that will be like this, which means there will be intersection of that is like far, like same distance from the origin. But in this case, like if you remember such an equation, like if I take the y alone, so that will be 2 over x. And that is a rational function. If you do not remember anything like that, so if you've never seen such a thing, you always can plug numbers, let's say 2, 1, 1, 2, and then get some like points, and then see how that graph looks like. But it will be a curve. So if you just plug a few points, you will obviously see it anyway. And that will be something like this. And that will go forever. And the same thing with the native version. So I can have like something like this. So anyway, so that looks like this. So now, like we are told there are like four intersection, and just imagine there is something similar to the circle. If that's the case, then your intersection might be somewhere like this. Okay, so four intersection. And then if you connect those, you get a like a figure with four side, and you just want to find the area. Like you can try finding those corners and go from there, but at the same time, it's kind of hard to deal with these. So which is why another thing we use, like when you try to find the area, especially with the coordinates, is the shoelace, which is why I'll try that one. So let's call this is x comma y. But let's say this is 2, 1, like for based on this example, that means if I swap these, like 1 and 2 will be another like solution. So let's say this is x is larger than y based on my drawing. So that means this point should be y comma x. Okay. And like another symmetry going on is this point is, if you reflect over this, you actually end up getting this. So the y value, whatever this value, is going to be same distance from origin. So which means this has to be negative y, and the x coordinate will be negative version of this. So this is going to be negative x and negative y. So actually the other way around. So the negative y. So negative y and negative x. Okay, so and then same as this one. So like the x coordinates was gonna be reflect over origin. So you will get negative x for this one. So if I want to write this negative x, and then the y value will be negative y. And you can always like make it some concrete numbers just to kind of converse. So as soon as we have the coordinates, we just write this. But while you are doing the shoelace, you have to write either counterclockwise order or clockwise order. Otherwise, it doesn't work. So we will just start with x comma y. And then I'm going to go counterclockwise. So y comma like x. And then you have negative x and negative y. And negative y and negative x. So you write the first one more time at the end, and then you start multiplying crossly. So that should be x squared. This is negative y squared. This is x squared. This is negative y squared, and then you multiply this. Then this is x squared with no minus in front, so that should be y squared, and then minus x squared. So as soon as you multiply this way, since this way looks like shoelace, so that's maybe we call it. So you add these guys, you add these guys. So if you add these guys, so you got 2 copies of y squared, and then minus 2 copies of x squared. When you add this, you got 2 copies of x squared minus 2 copies of like y squared. Okay, so then as soon as we have this, the shoelace like works like kind of similar to area. We just take the 1/2, but we take the 1/2 of the absolute difference between these two sums. So if I subtract this from this or this from that, either way that works because we are gonna like take the absolute value anyway. So that should give us 2y squared minus 2x squared. And minus version of this, like the negation of this will be negative 2x squared plus 2y squared. And we have 4y squared minus 4x squared if you multiply by 1/2. So you end up getting 2 times like y squared minus x squared. Okay, this is somehow helpful, at least promising, because we are looking for this guy. As long as we find this expression, then we are done. But we never use these numbers, so we should use it. So, but when you look at these two in equation, this what we are looking, we kind of can relate these easily, because if I square this like y squared minus x squared, if I square this by square a binomial, that will give us like y to the 4th minus 2y squared x squared plus the x to the 4th power. This is really nice because this guy plus this guy is actually 48. So that was known. And then xy was 2. So if you square that, that will be 4 times 2, which is going to be 8. So minus 8. So that should give us just 40. And this is the square is 40. So meaning that y squared minus x squared like is 2 root 10. But this is not what we are interested in. We are looking for twice of this, which will be just our answer for root 10. So like it was like probably very challenging question because that's 29. But when you look at the Shoelace approach, this is actually like way better than the Soviet system algebraically, even though it's possible, but I wouldn't bother myself to do so. So this is the answer for root 10. Anyway, I'll see you in the next video.